and there's no security tokens in the response. So the service requester just gets back the data inflow, but has no idea where it came from. It's not signed, no authentication, no integrity. Don't know where I got it from. If you think about it, a lot of times this real sensitive data is coming back in the response, not in the request. Insecure cryptographic usage, number 6. So as I alluded to, we have a box of Legos provided to us by Microsoft, IBM, the other standards vendors, but we don't have clear guidance on exactly how to use them. And there's a really nice treatment of exactly this subject in a paper that Brad Hill wrote from ISEC Partners, and I'd encourage you to Google around for that one. I don't have the link on the slide here, but Brad Hill's paper was at, I believe, at Black Hat last year, and talks exactly about this issue. So the issue is misuse, misadaptation of web services security mechanisms. That's the new web services vulnerability that we're talking about here in number 6. Of course, all of the same issues that we've had with people inventing their own algorithms, inventing their own schemes, and their own new ROT 13 still apply. All the same things we had in OWASP top 10 issue of this all still apply, but we have some new ones. The best example, the main example we've seen in the wild was various vendors in the early days started to implement WS security with digital signature. And so they implemented the service provider that said, I'm going to get in a SOAP message. I know that SOAP by default has no authentication, no integrity. So I'm going to make sure that all these messages are signed, or I'm not going to accept them. So the service providers started checking to see if the message was signed. So that was a good start. Problem was, these same service providers forgot to check if they trusted who signed it. So they just checked for presence of a signature and didn't check if they trusted who signed it. So again, these are all things that are left up to implementers. So standards get us part of the way down the field, but definitely nowhere near all the way. And we'll see actually an example of this that happened about 3 weeks ago at Google of a similar issue here. Just building a little suspense for number 10. So, number 7, insecure communications. As much as I like to make fun of SSL because people think it's a complete solution, not having SSL turns out to be a bad thing, even for web services, for many of the same reasons, and one new one. SAML and WS security tokens are, of course, vulnerable. Any of the security tokens we use are vulnerable to timing attacks, replay attacks, and so on. So we want to have SSL in place to minimize the ability of the attacker to sniff the traffic and get the token. So our SAML assertion looks like this truncated SAML assertion, has session index, has authentication indexes, all the things that you would use on the back end to look up the SAML assertion and make sure it's valid. If you pass it over HTTP, it's all sent in the clear and can be replayed. And if you pass it over SSL, of course, you've minimized the attacker's ability to do that. So here we're talking about passing the secret key around and letting people have access to it if we're using insecure communications, such as HTTP. Okay, failure to restrict access. Sometimes the only protection for a service is that the method calls are not presented to unauthorized users. So probably the best example I know of this, at least in enterprise computing, is MQ series. So MQ series has authorization with no authentication in many cases, how it's implemented, which I've never quite figured out how that worked. But basically, if you know where the MQ is listening, you can put a message on it. And that MQ then connects you to the mainframe, and usually the thing that runs your entire book of business. This is also relevant, of course, because again, we're using web services in the first place to provide interoperability. We have a bunch of legacy stuff on the back end that actually runs the business. It's why we get our paycheck every 2 weeks. But it's hard to talk to. Not everybody wants to have an MQ listener running on every single web server. So you put a web service in between it, make it easier to talk to. So the web service, in fact, then is a gateway. It also can be thought of as a gateway vulnerability. So just like we have gateway drugs, where you start smoking marijuana and you wind up on heroin, you may put a web service in front of your mainframe, and then by the end of it, if it gets exploited, your sysadmin is smoking marijuana. So or worse. So the issue here, again, we have tools that are automatically generating things, and we have a very, very large attack surface and configuration for people to traverse through to have any assurance in all these things. Okay, so now that sort of completes the 8 that we're reusing from OWASP 10. Our 2 new ones, the first one is broken XML. So as you might have guessed, since we have a message document paradigm for our integration, there's lots of attack surface, lots of vulnerabilities in this case. So we're not using a binary integration like EJB client talking into EJB server. The integration is based on message document such as XML. So there's 2 main ways we can see vulnerabilities coming through. We can see structural vulnerabilities through types, and then behavior through bad parsing or bad validation. So in this case, there's really sort of a decision tree that you can work through to find vulnerabilities in broken XML. But first is not validating against a schema at all, which I would say at least half the time, if not more, is the case. So no validation whatsoever. So you're taking in untyped data and then making business decisions on it. The second thing that you may do is maybe using the wrong schema, such as a DTD, which actually can directly lead to XDOS. Microsoft and IBM and other vendors have been good about pushing people away from using DTDs, and it's not allowed in the current spec. Needless to say, lots of people still use DTDs instead of XSD. And every DTD parser that I have seen is vulnerable to XDOS, XML denial service attacks, through recursion and other things. And then finally, we could be using we could be schema validating. We could be using XSD instead of DTD, so we could be doing both of those things correctly. But if we validate against a weak schema or a lax schema, we really haven't solved our problem. So we really need a hardened schema, ideally, that would set things like maximum lengths, that limit the character sets, enforce types and encoding, and so on. So it's really a 3-part rule when we look at the vulnerabilities of XML, which is, are we doing schema validation at all? Are we doing it against the correct schema? And then have we actually hardened the schema? So those are the decision tree, and we'll go through a number of examples in the top 10 web services document for you to look through on those. And then the last issue, identity misuse, number 10. So identity is the basis of the claims and assertions in web services. And then the identity is consumed to make 3 important decisions. Routing decisions. Where am I going to route this message across the ESB, across all of my different parts of my system, across MQ series, get back to SAP, get back to PeopleSoft, what have you. Make business logic decisions based on identity. So sometimes it's funny, I was in a meeting not too long ago with a client, and he was an application architect. I was helping with security architecture, and he said, why do the security people even care about identity? It's actually an application issue. And if you think about it, he's actually partially correct, because identity is where the subjective meets the objective, and basically every single application decision is going to be based on an identity. Of course, the part that we would like to care about as security people is that we've protected that identity, so the quality of the decision that's made when the subjective meets the objective is a good one from a policy standpoint. And the last part, of course, everybody thinks about identity as an access control mechanism, and it certainly is that.